Modi sir, shall we start?
Ma'am, please wait for 2 to 3 minutes.
Okay, okay.
ચાલુ થાય તો ખાલી સ્ટાર્ટ દબાઈ દેજો ને. હા, ખાલી સ્ટાર્ટ મેં મૂક્યું જ છે. બધું રેડી જ છે. અત્યારે આવું દેખાય છે. Hello, ma'am.
Yes, sir. Shall
Ma'am,
we
please
start?
start the session.
Okay. Good morning, all of you. Um, Today we have with us in our room Dr. Manoj Kumar Gupta. He is presently working as senior scientist in Institute for Plasma Research. He is the head for the Engineering Design and Analysis section, Mechanical. He has worked as leading member in the mega project from Government of India, Laser Interferometer Gravitational Wave Observatory. He has very wide experience of almost 22 years in designing, fabricating, installing, and commissioning of various large-scale systems like vacuum, cryogenic, structural systems. He has worked in different areas like structural, thermal, CFD, materials, etc. He has many research publications in well-known journals. He is a reviewer of many journals. He has done his diploma, PhD in mechanical engineering. He is mentoring many projects also. Sir has many certificate courses from IITs, and he is continuously delivering lectures in LD Engineering College, Nirma, PDPU, Delhi Technological University, Indus, etc. He is also Board of Studies member for GTU, Indus, LDRP, etc. He has been awarded many awards from different Indian institutes and foreign bodies. He had to his credit, a gold medal also. He has received the award as a part of LEGO team, 2016 Grubber Cosmology Prize by US, 2017 Royal Astronomical Society Group Achievement Award by UK. He has a special breakthrough prize in fundamental physics by US as a part of Nobel Prize in 2017. He has been practicing, applying, and regularly delivering lectures on Bhagavad Gita also on different platforms. He is also a good motivator. His personal life is simple and dedicated to society. Sir, we are very much grateful to have you with us, and I welcome you on behalf of FDP team and Mechanical Engineering Department, Government Engineering College, Bharuch. Sir, I invite you to start with the session.
Thank you very much, madam.
Welcome, sir.
Thank you for giving me opportunity to give some insights regarding my experience. So thanks, Professor Ashish Modi and Professor C.K. Makwana also, who has given me this opportunity to share my experience. Should I share?
Yes, yes, sir. So there is upside arrow key near mic key.
Yes, I am. Yes, now I'm listening. Are you able to see now?
Yes, sir.
I should go in slide mode. Now you are able to see?
Sir, it is not in a presentation mode. It is in a slide mode only.
I have given in presentation mode. No. On my PC it is showing in presentation mode on the slide mode only.
Okay. Sir, just go to presentation mode.
Again, I will stop sharing. It is coming in presentation or no? Still.
Sir, not sir. Sir, kindly share your full screen instead of a particular file.
Okay.
Full screen.
Okay. I will share the full screen now. Entire screen. It is coming now?
Yes, sir. Perfectly
Okay.
all right, sir.
Okay, thank you very much. So as you are already going through a lot of concepts in the FE and hands-on trainings are also done, various timing scales and this thing. So as we have to apply all those concepts in the means practical form, so we should know that how we can apply, because the theoretical part and solving the only verification or benchmarking problems will be given only just to start with, but it is not that we can apply all the things when we are doing the actual problem. Okay. So for that, I have made some conceptual practical aspects for the ANSYS, which will be applied during any kind of application when you will start to solve the problem in the research organization or in the R&D organization. So I am giving the practical aspects for that, and before that, I will start with my institute that where I am working. So this is brief introduction that this institute has been emerged in 1986, and the objective was to do research in nuclear fusion, basics and industrial application of the plasmas. And we have built one machine in called Aditya, which was the India's first indigenous tokamak reactors, which became operational, and it is still in the operation. And we have once again we have modified a lot of things into this machine, Aditya machine, and we took decision based on our uh, analysis purpose. After that only we were able to do it. Then 1994 we have started working on the steady state superconducting tokamak, which is called SST1. So this is a very complicated machine, and I will show that how complicated it is, and here we have done analysis and how the analysis has been taking part into that. In 1997, FCIPT was created to transfer the IPR's know-how in plasma to benefit the Indian industries. So FCIPT means one is industrial division we have where we give the plasma industry part, means how it is can be used in the industry, Indian industries. So we have done a lot of project into that, and 2005 India joins the International Thermonuclear Experimental Reactor, which is called ITER program. So ITER is also one of the domestic agency in the ITER. So fusion energy is just nothing but the one kind of energy which is used uh, for different purposes. And as we know that fissile fuels are going to be decay and in near future, so we have only option of the fusion energy. So as we are working on the tokamak, which is called a machine for the fusion, so we have different kind of fields there, which is called toroidal field. This is a toroidal field, and one is the colloidal field. So I will just use that one. So this is a toroidal field is there, and one is the colloidal field. So we have to uh, give the current from that magnetic field is generating, and different kind of magnetic field is helical. In this kind, you can see this is the helical kind of, and this is the plasma. As we are seeing, this is called tokamak. The torus kind of thing is there. This is called tokamak. So this one field is in the toroidal direction, another field is in colloidal direction. When both the fields are merged, then it gives the some helical kind of thing. So if we will see here, this plasma is also the magnetic fluid. We can see that plasma is also magnetic fluid. So when we are doing some analysis and practically we are applying, then it is working as a fluid also. Simultaneously, we have to apply the electromagnetic fields and different theories of the electromagnetic and the CFD. fluid theory. Then only we are able to see the actual behavior of that. So technology which we are using for our tokamaks are different kind of technology. One is the cryogenics and superconducting technology, because all the magnets are from the superconducting magnets we are using. So for that we need the cryogenics. We are using different diagnostic means to measure the different parameters for the plasma, and then we are using beam technology. We are putting the beams for the heating purpose, different kind of beams. We are using the radio frequency and microwaves also for giving the currents and for accelerating the currents. We are using power engineering. We are using advanced material manufacturing technique, robotics, and different controls and data acquisition systems. So this is the one picture. You can see this is Aditya. It looks, it is very complicated machine is inside this place, and it is designed and it has been built indigenously. We have built it in 1986 we have started. 1989 we have given the operational. Until then it is operational, but here we have used the copper magnets. Copper magnets are used, so we cannot go for very high current, and we cannot prolong the operation of that copper magnet. So that's why it is not continuously operating system. So this is the pulsed operation. These are some different parameters where plasma duration is only 250 milliseconds. So this is the India and different diagnostics for this Aditya we have made. This is the indigenous development of many diagnostics for this system, and we have tested the RF heating and current drive system for this machine. A lot of heavy structures you will see, these are due to some forces are coming. Generally we use the forces, structural forces generally we are used, that if some weight is coming or self weight is coming, then we are using the some forces, or that weight load is coming then. But here we will see that major force is the electromagnetic force. So whenever we are switching on the electromagnets, then the current is flowing. This current and the magnet field, they are mixing together, or they are interacting together, and they are generating the electromagnetic force. The force directions will be a little bit different in different directions. So we have to strengthen our structure, we have to design our structure in such a way that it should take the such kind of loads in the different directions, and load is not only the one parameters, and it should not deform also. Suppose if it is taking load but it is deformed, then next time we will not get the same kind of electromagnetic profile or magnetic field profile. We will not get it here. So like that, we got a lot of experience from this machine, and then we went to the SST1 design, another machine we have built up here. So this is the one more machine which is called SST1 machine. You can see this machine, and here it is also very big machine for as per Indian perspective, and this is the only false floor. Below that all the structures, all the supports and everything is there. So it is two tier structure is there. One is below that, and some part of the structure is dig into that, and for that to take the loads. Here many kind of loads are coming. Here the cryogenic systems are there, some vacuum systems are there, some valves are there. This is the cryostat is there, inside the vacuum vessel is there. So a lot of interference you will see that. So if we are going for some designing something, then we have to look all around that what kind of loads can come from all over these systems and different kind of system. This is not only our system will be installed there. So a lot of interaction and multi-physics should be known. Suppose this is the, you can see here, these are the some copper bus bars are coming, which will supply the magnets, our magnets. So for that, a lot of structure and this how much magnetic field it will generate, how much distance it will cover, and then the eddy currents will be generated, how to break those eddy currents, and so that the force should not be very high, and we can arrest those force also or not. So everything we have to see into this. So this is not easy system. It looks easy when we uh, take the any component, a small component, NTA or something, and then we are doing some analysis. At that time, it looks that okay, we are designing only a small component, but when it comes into system, then different kinds of loads are coming. Suppose somebody is walking on this false floor, which we have not analyzed till now. So then false floor, a lot of vibration will come. But when you are designing separate system, at that time you have not taken any kind of vibration. Then the system will fail at that time. So we have to consider a lot when we are going into the practical field or industrial field. So if many persons will walk through this, then a lot of vibration will come, and how to arrest those vibration, where it will be transferred. So those things, live load, we have to take into the consideration, not only the dead weight load. Yeah. So this is the one machine where our objective was the physics and technology challenges, and the duration in Aditya was only 250 milliseconds, but here we have taken the challenge for the 1000 second. So if you will see the features, it is the first of its kind machine, and we have to shape the hot plasma for 1000 second. And here we have used, there was the copper magnetic, copper magnets were there, and now we are using the cryogenic superconductors are there. So all the magnets here we are using the superconductive magnets. And this is the one more machine where we are using our all the experiences for the design of the ITER system, which is very big system. If you will see this machine, and this machine, this is the height. Height is approximately 29 meters is height, and this width or this diameter, you can say this is also 30 meters. So this is 30 meter by 30 meter machine approximately. So this is very high mechanical system, very good mechanical system is there, in which vacuum vessel sector is there, which is made of double wall system. Yeah. And we have blanket module, we have different kind of materials inside that, so different kind of joining techniques we have to develop for this, and everything has to be, when it is closed, then it is very difficult to access this kind of machine from there. Then remote handling machine we have to develop so that we can see, and then this is the toroidal field magnet, and here is the diverter cassette. Means different names are there for according to the different fields. Yeah. And remote maintenance diverter central solenoid in this solenoid is there. So this is very big machine and very challenging machine. So IPR has one separate division or separate part, separate as a project, where a lot of engineers are working on each and every part from the mechanical side point of view. So now I am going to tell about that analysis, how we are doing and when we are doing. So what is the reason for the analysis purpose? As it saves our effort, time and money during the development and innovation of this system. When we have to develop this, you have seen very big system, then it's our efforts are very less in building before that. So it helps in improving the system performance and reliability also. whenever we are making any system, then performance or reliability can be improved by doing some analysis point of view. Yeah. Why it is not coming? Suppose we have designed for some 80% efficiency, if it is giving 60%, then we'll improve it. We can see by analysis that where we are lacking and what parameters are coming. It reduces our time to develop the system a lot. So when we are doing, because in R&D you can see every system is new of its kind. It is not repeatable system. It is not industry. So once we have developed only product, and then we continue carry on. It is not like that, and it provides the physical prototype from virtual right from the first time. Means when we are making any system, if we have the experience, a nice experience, then we can utilize that experience so that in first time whatever prototype we are making, it will be perfect and it can be used. So we can use the virtual prototype as a for the analysis, and then we can go for the physical prototype. Many sometimes many things are coming during when we are fabricating or installing the system. At that time we have to once again some modification, something we have to do. Then again we have to do some analysis that how much impact it is giving to our stress criteria or temperature or whatever model we are going. So we have to uh, take so many decisions before analysis in the ANSYS. As you are going through ANSYS, that's why I am giving on ANSYS, and we are also using the ANSYS here. So before starting any analysis, few important points are there which should be kept in mind. First, we have to check which module is appropriate for your analysis. Either we are doing the structure analysis or thermal, CFD or electromagnetic. So if we are not clear about what we are going to do, then we cannot choose the perfect module for that, because nowadays a multi-physics is coming. So sometimes many combination is also used here. Then which type of analysis is required? Either it is steady state is required or transient is required. Mostly times we see that when the students are doing or something, they are going for the steady state analysis generally. But sometimes this transient is very important, because this gives the sudden change in the system, and then it becomes a steady state. So it depends upon the experience that transient is required or not required. Then we have to see the size of the problem of the system. Uh, Either we have to make the complete system or we have to make a part of that system. So problem is very big or very small, a system is big or small, that size we have to see. Then computing resources available means what resources we have at present moment, and will it be able to solve our problem or size, whatever size we have taken. So can be solved by using that computer resources. If not, then we have to divide the problem into different number of parts. Once again, then we have to combine them. So, and one more aspect which initially we are not looking, that results required. If we are looking initially that what results we want, that either into stress intensity or pressure drop we want, or magnetic field we want, or heat transfer coefficient or velocity, means whatever we want. So can that module is able to give or not? Sometimes we use the module and we are limited that this module cannot give this characteristics. So we are just wasting our time. So we have to see that what kind of things we can provide or what kinds of results we are requiring for that. Then we have to include the physical models for our analysis. It is very important that which physical model we have to take. Either we have to take the whole model or we have to take the part of that model. for analysis purpose. Because physical models which we are going to analysis is dependent upon the nearby so many systems. So which physical model is used for our analysis, and what kind of cut or what kind of small features we want to include in that physical models, that is also very important. Then different modeling options are there to create a model nowadays, and its compatibility with the analysis software. Whenever we are modeling different models for our analysis, then we have to see that the software is giving the required output or not. It is giving mostly nowadays, mostly modeling softwares are very good softwares. They are giving in some step file or some neutral format files which we can use. But once again, we have to check that all the features are transferring or not. If not, then we have to repair that model once again. So when we are making the model, at that time, extra things should not be there. Modeling extra things are there, then it is not affecting too much. But if suppose some surfaces are there, which are extra surfaces are there, but in modeling it is okay. And when we are taking this model into our system, then extra surfaces and other things are creating the problem and not giving the perfect results for the analysis. This we have seen a lot of problem when we are modeling. And when we are modeling anything, then since beginning we have to keep in mind that it has to be analyzed. Otherwise, we are making unnecessary features which we have to remove once again. So one is the actual model is there. Then we have to convert it into the analysis model. So this is where again we are time consuming and we are doing this thing. So if you are having initially that which modeling things we have to do for analysis, so we have to concentrate only on that. Then next is the assumptions which we are giving to simplify the problem. That can be do take the symmetry or it is the periodic things for the problem. So if it is periodic, then we have to give that assumption, then which model and how much part it has to be taken into the consideration. So all these points are decision aspects. Some more points are also there to take the decision before analysis. This is not after the analysis. Many persons take the decision, these decisions after the analysis. They make the model as per that, and they don't know that what results we require. They don't know the computing resources, and this then when problem comes at that time they think, okay, we have to go for this. So, but this all everything needs a little bit experience. Then if we are simplifying the assumptions, then we have to see the effect on the results. This is not that assumptions are simply taken and results are not considered, because many times we are seeing that we simplify the assumptions so that we can solve the problem, but we don't know the what it is giving for the results. So this is one of the important aspect, that before making any assumptions or doing the analysis, we have to see what impacts it's giving on the results. The requirement for the degree of accuracy. This is one of the important parameters, that where we want the accurate things, what part we want the accurate things, where we are focusing our results and everything. So this depend upon the accuracy kind of thing. Then size of the mesh and type of the mesh, that which kind of mesh is available for us and what kind of mesh we have to do. What will be the size of the mesh we have to do. It is to be very fine or coarse or something, because a lot of things are required to the analysis. Then interface between the different parts. That one part, if we are analyzing, then if how it will behave with the another part, what will be the interface, and if different materials are there, then interface should be perfect, so that the force or deformation can be transferred from one part to another part. If it is not perfectly interface, then we cannot get very good things. Then metal properties, enough for analysis or more required here. Generally, we are seeing that whatever is metal properties are available in that our module, we are using that much. But we are not going to detail of that. That whatever metal property we have given, it is standard metal properties, then okay, we can use it. If not, then we have to see that either it is the isotropic, orthotropic, or anisotropic. We have to check each and every kind of, and whatever we are using material, it's always better that if we try to characterize that material and whatever properties we are getting and we are putting, then our analysis will be very good analysis, because we cannot depend upon only the standard metal properties. Then next is we have to see that it is the problem of linear nature or non-linear nature. Non-linear means large reflection is coming, or stress stiffenings are there, or some different elastic materials are there. So a lot of non-linearity is there. So, but generally we are taking the linear problems, and it gives some kind of estimation linear. But if the material is non-linear, then we have to take care of all the non-linear properties for that. Otherwise, our results will not be very good. Then finally, we have to see the time required for the results. Suppose if we have given a lot of refinement, and we have taken very big model, we have taken number of elements, so many in this, and we want to complete the analysis certain time or something and some accuracy, then we should look to the time required and how it can be means optimize the time requirement. So for reducing the time requirement and something, we can do a lot of things as we are doing here. IPR also practical problems we are solving with the limited time also, because sometimes we don't have a lot of time for that. So how much time is required for this analysis? Otherwise, many problems will go up to the 15 days also, as we are doing. So sometimes we need very thorough and very deep. Then we are running the problems on the high computing systems, and it is runs approximately 10 to 15 days continuously. So time is also one of the decision aspect when we have to give our results to the persons or the management. So for all those decisions we have to take before analysis, and for that we need some fundamental concepts before taking any kind of decision. This everything I am telling as per the experiences what we have. So we have to understand the physics behind the finite element method. So this is not, that's why this course conducting the course is very important for those who want to go for the analysis, data analysis part indeed. So theory already has been taught to you in different sessions. I'm not going for the theory, but we have to see that few points fundamentals we have to clear from those theories, that inputs are also very important, because small error in the inputs can result in the large error in the solution. So suppose if we are going for different approach or wrong approach we have selected, so small error, then we will not get the good results. Many times we take the wrong assumptions we take initially, and when results are coming, at that time we are feeling, oh, we have taken this assumption which is not good assumption. and we should not take, suppose symmetry assumptions we have taken, or periodicity, something, any assumptions we have taken. And the metal property is one of the important criteria. As we are facing now that some material we are using, some Kapton material we are using for the analysis. So different kind of Kaptons are available for that. So, but we have to take the same grade, same metal property. So we are going through the metal property check outside. Then those metal property we have to put. So wrong metal properties will take, then it will give the different results. In suppose if you are doing the stainless steel, but stainless steel is not only one grade, it has a lot of grades into that. Yeah. So which cases we are taking, how much difference it is taking, what kind of properties it is making. So we have to check all those things. And what we have to check that which assumption is taking part in FEM or which is not taking part in FEM. Suppose some assumption we have taken which is not taking part in, then it's no need to go through or to focus on that. Similarly, metal property is important for this analysis. So we have to concentrate on those properties which are taking part in the analysis. Suppose we are doing some thermal analysis, then some specific heat is taking part or some thermal conductivity is taking part, and you are focusing on the stress part, means tensile strength, yield strength on this. So like that, this will not help us. So we have to check that which kind of problem we are doing and which property is taking part properly. So those properties very very important properties. Suppose specifically it is taking part a lot in your analysis, then it should be perfect. Otherwise, it will not give the proper results. So every different kind of metals, the property changes differently. Suppose SS304L is there and SS316L is there. So there is a lot of difference in those properties. But overall property may be same, but internal property which is taking part, we have to see on that property. So software may seem very easy to use, but it can also create wrong answer easily. So whenever we are doing anything, then if we don't know proper use of that software, then a lot of default settings are there. Mostly the settings will work, but if your problem is of specific nature, then we have to see all those options which are default, that where we can change it. Otherwise, small change in that, it will give the different kind of results, and we cannot be able to solve the problem properly. So it looks many times okay. NCS is very very easy software. Or nowadays it became very easy and very handy. UI is very good. Okay, these are for initial purpose, but when we are going into the deep or some R&D problems, then a lot of things are coming out from that software. Okay, we are not able to do this, we are not able to do this. That's why all those software companies, they are working with the R&D companies, and whatever problems they are facing, then they are removing those problems, and then they are launching their new versions. So we are working on different problems. Still, problems are going on. A lot of things. Then we have to understand the method of solution for proper results. For continuum problems, either we have to use the analytical approach or we have to do the numerical things. In analytical, typically we are used to solve the simple problems. We do some calculation because of simple problems and we get the very accurate results also. But if we are going from numerical techniques, then it is used applicable to the complex problems, and proper popular method due to ability powerful devices are there nowadays, because the computer resources are too high, and availability is also good. So it is used for the complex problems and we get the some approximate results. But yes, we get the results which we cannot solve by analytical means. So that is also very useful that in numerical the complex problem can be solved. So we have to understand the basics of the FEM. So I hope that you have taken full benefit of the course which is arranged at your place, and so that you can understand the basics means backside what the software is doing and how it is affecting our solution and our results. So those are the main problems we have to say. But in any case, either it is complex problem, either it is simple problem, I always request everyone not to go directly. Some calculation should be there, background of this. At least some orders we can know that this stress will come up to this order or this exact value we cannot know, but at least some. That's why basics are important for that. Then we have to see the characteristics of that approximate mathematical numerical solution techniques which is used. Why that? Because if you go for any kind of solution, a different kind of solvers are there. Which solver is best for your purpose? That if you know the basics, then only you can choose them. Otherwise, generally people are saying, okay, take this approach, take this approach. Only this solver is okay. This will give this. But if you know the basic, then only you can see for that. So software use you should know that for solution, how to use and solution, what kind of things we have to see in the different options present in the solution. If you are going for any solution, a lot of parameters are there which you can play with that. So continuum, any system is there, continuum is there, then it is divided into the finite size elements. So how many elements we have to decide, what kind of elements are there. So we have to see that characteristic also from FEM. The governing equations which governs the whole physics for the entire body used for each individual element. We have to know that each individual element uses those governing equations, and then it is the combining those governing equations to get the proper solution of the whole container. So for each elements, it gives the governing equation, then it combines them. But when it is combining different elements, we have to check that continuity between the elements should be governed by the different functions and its derivatives. It is otherwise the continuity should not be break between the elements. If it is breaking at some point, then it means it is not transferring the things or different parameters, different rates from one place to another place. It solves the entire reason by summation of each elemental solutions, and same calculations are performed for each element makes this method suitable for computer procedure, because it will be very difficult for us to solve a lot of elements or problems and then to combine them. So we have to take the help of the computer hidden procedural or resources. The more important parameters is the accuracy. Accuracy in the finite element analysis is very important process, and it primarily depends upon the number of elements in the model. Suppose if we have the more number of elements, smaller elements, then we can get more accuracy, because the smaller elements can capture all the features at the some particular place as well. So more accuracy will be there. Errors will be less there. But if we are going for more and more accurate and more elements, then more unknowns are there. If more unknowns are there, means more equations we have to produce. More equations means more computer resources is required. More computer resource means more time is required. So it is not always preferable that more elements means, suppose you're taking 1 mm element, 2 mm elements, or 0.01 mm elements. Okay, 0.01 element is okay, but we have to see that how much smaller we can take so that we can solve within the proper time, within the limited resources we have. But if we are going at some place only, then where we can refine the mess, other places no need to refine such kind of mess. But we have to see by experience that when what kind of elements we have to take, what size of element we have to take, what shape of element we have to take. If 2D elements are there, then we can take the triangles, quadrilaterals are there, 3D elements are there, then tetrahedron or this bricks elements are there. And one more is that requirements of mid-side nodes are there or not. If we have the non-linear problems or we need more accurate layers or mid-side node or higher degree of freedoms are required or not. So mid-side nodes are there or not. What is the safe function? Linear is there, quadratic safe function is there. Based on that, we have to decide that we have to take the bits and nodes or not. Then proper connection should be there between the different nodes. Yeah. If proper connection is not there, then it is very very difficult. Yeah. So we have to understand the node also, that what is the role a node is playing into the analysis. So we have to understand the importance of node. Nodes are generally used to calculate the basic relating quantity like the formation or temperature. So nodes are very very important. How many nodes are there? How to uh, give the different boundary conditions into that. You have to know the node behavior as per the degree of freedom. Yeah. That what kind of degree of freedom is required on each node. Yeah. So node can have multiple degree of freedom. Suppose solid elements are there, then it needs only 3D of D of per node. But if it is the shell or beam element or something, then 6 degree of freedom is required. Yeah. So all the three displacement and rotational degree of freedom is required. So we should know that which kind of elements we are taking and what the D of for each node is there. That's why based on that, a different number of equations are developed here. So if we will see one F equation for one DOF, it means that the total size of the HMS matrix is equal to the total number of nodes into number of degree of freedom per node. As example, I have given that sort of solid elements is there. So I told the solid elements has the 3D of per node, and it has 100 nodes. This solid means our system has 100 nodes. So 100 into 3 means 300 F equations will be generated. It means one F equation is generated as per the one DOF. So we have 100 nodes and 3 degree of freedom. So each node has 3 equation of so 100 nodes has the 300 F equation. So you can see number of, if we are increasing the number of nodes or number of DOF, then a lot of F equations has to be solved by this. Hence the solution will provide whenever we are solving any analysis, solving anything, then we are just seeing that the results are provided and the solution is provided, the magnitude and direction on each DF on each node. You will see that when we are getting the results, then it is calculating the magnitude and direction for each degree of freedom at each node. So by that, then they are combining that thing and getting the results. So node is very very important part of the analysis. Yeah. So boundary condition and inputs, whatever we provide, generally we see that we provide the inputs and boundary condition only some surface, outside surface or some body. This. But what happens later on within the software? then these boundary conditions and inputs, it is to be just transferred to the nodes for solving the problem. So all the boundary condition inputs, whatever we are giving as a part of the body, as a surface, line, or some points, or some volume, then all the things, condition inputs, they are transferred to the nodes, and nodes are solving those equations. At each node, they are making the Cauchy equation, and they are solving those equations for that, and they are giving the results. So we have to understand the importance of the nodes. So if there are so many nodes are there, which are hanging nodes, which are not taking part in the analysis, then it is not good for that analysis. So now I'm going for the analysis types which we are using mostly. We have, in IPR also we are using the structural, thermal, fluid, and electromagnetic. Most probably this 90% we are using these four modules we are using. But suppose structural is there. In structural, this is not only static we are using. We are using the transient also, and we are using the explicit dynamics also. So means inside that we are using a different kind of analysis. And mostly, many times we are using the combination, because in our institute we are not using only structure or only thermal. This mostly times it is a combination of different physics. Yeah. So either we can directly combine them, two physics together we can combine, or we can give in the sequential combination. Means we can solve for one physics, and then the results or the output comes from one physics, then it is given for the another kind of physics. Those inputs are giving another kind of physics. So as per the analysis types, it depends upon the physics. Either we are doing steady state or static things. If you are saying that we are aiming for end results and slow changes their body and not too much changes there, or deformation is not too high, or the temperature is not giving very high or something, slow changes there and end results, then we can go for the static analysis. But if the changes are very fast there, and these are changes are affecting our analysis or system, then we have to go for the dynamic or transient analysis. So as per the behavior of the physical phenomena, either we have to choose the linear or non-linear. So linear gives very good approximation for many physical phenomena, but very few physical phenomena truly behave in a linear fashion. If you will see in many different systems, they are not behaving in a linear fashion. So we have to go for non-linear reasons. This will give the very accurate results for geometric, metal, non-linearity. If geometry has non-linearity or metal are non-linear are there, then we have to go for non-linear analysis, and it gives very good results, but more complicated to set up. If we want to do the analysis, then setup procedure, pre-processing, and what kind of inputs are going, they are more complicated, and we have to solve them, then getting results. Mostly problems are coming for non-linear things. The convergence is not guaranteed that it is converging or not converging. Either it is taking so much time, but after we have run some problem up to 1 week, then we see that it is not, if it is converging, then we have to just reject that analysis and do analysis that what problems it is facing, and very long solution time it is taking, and a lot of computing resources, very high computing resources are required. We have the high performance computing facility here, so we are using that facility for, because our own systems will not work for the mostly of the problems, because more accurate and big data is required to feed as input here. This one application, just I want to show that we are doing suppose some analysis for that. This mechanical module we have used, suppose structural module we have used the CFD. So cryogenic tanks, we have a lot of cryogenic tanks here in IPR. जो है, we have LN2 tanks, three storage LN2 tanks are there, which are horizontal and 30,000, 33,000 liter capacity is there in each tank. And then we are having the helium, liquid helium tanks are there, Jivars are there, a lot of things. So this I am taking only the one problem here, that how we are approaching to that. So their tangent analysis with numerous startup and shutdown cycles has been analyzed. We have analyzed a lot of things without having the actual performance cycle, because in cryogenic tanks, if you will see, it is storing the cryogens, and then it is having the temperature effects for that. Yeah, and within that, as the heat is always transferring from outside to inside, so heat is always inleak from that. So a lot of boiling is taking place always there, and this boiling will give the different kind of CFD inside that, and this can create the some vibration kind of things into that. So we have to check all those things when we are filling this cryogenics. When we are filling some tanks, the cryogenics, yeah, then at that time the vessel is at the 300 degree uh, Kelvin, 300 Kelvin at that time. And when we insert any low temperature, and you can see any cryogenic tank has to be filled from the bottom, not from the top. Yeah. So we have to take care for all those things. So if we are filling from the bottom side, then it will give the low temperature is coming in contact with the high temperature. Immediately it will evaporate within this, and evaporation will take place, and different kind of heats will be there. It will convert into the vapor. The problem for the cryogenics is, one of the problem is that uh, we are getting, if 1 liter of cryogen is there, and if it is evaporating, then it will become the 800 liters of the vapor. So you can see that one bar is pressure, then it can go up to the 800 bars. So it is very very slow. We have to cool down, and when we will cool it, then at that time this coefficient of thermal expansion will also play the role, because it will try to contract. So whenever it is trying to contract, then this all the loads will come into the legs or some support structures is coming. Yeah. So we have to cool down slowly, 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 and then we have to fill it up. When it is filled up, then continuously heat is transferring to this, because you cannot make the any system which is the 100% insulated. Yeah. So due to this heat transfer, every time some boiling is there, then it is converting to the vapor, then vapor is converting into the liquid. Some cycles are there, so we are using many kind of CFD process into that, that how the flow is consisting, how the flow is going through within that, and what kind of forces it is giving into that. So shutdown cycle, and then similarly we have to, when we have to means empty this storage tank, again the low temperature will become the high temperature. So this is the thermal cycling taking place. Due to this thermal cycling, a lot of fatigue stresses are generated into the cryogenic system, and tanks are this supports are very very important, because temperature is changing will give the support height change, or and due to the contraction period, this and their lifetime also changing. So vibration boiling and all the cryogenic tank is looking very simple from outside, but this is not outside simple. These are always the two layer tanks are there. So you can see only one layer tile. Inside that one more layer is there. So two layers they are connected with the different kind of internal support structure. So those support structures are also very important. And metal property for those supports, strength of those supports and other things, these are playing major role between them. Otherwise, outside you will see that this is okay, and inside you will see then a lot of problems are happening within that. So analysis is making us to decide that what thickness of the supports are required, what kind of this, so that we can make the system very perfectly and within one go. Otherwise, if we will do R&D outside in prototypes, and sometimes we need small prototypes for making this whatever we are getting the results from the analysis, it is working well or not. So this also I have given this little that what applications we are doing. So many applications we are doing. This is just one of them. So I am going for my conclusions that fundamental concepts are very important before executing any kind of analysis, and we have to do some basic calculation for the new problem so that order of the magnitude can be verified. We miss this part mostly. We don't do any basic calculation. Directly we go for the analysis and we get some beautiful colored pictures for that. So this is not the case. We have to do some basic calculation. We have to try to benchmark the problem which is already given, which rates are known, just to have the confidence and to see the boundary condition assumptions we are making only for that purpose, and then use the appropriate solver so that simulation is fully converged. Otherwise, solver is not proper, then solution will not converge and it will not give proper results. So analyze the results properly so that you can interpret the behavior properly. If some results are coming, we are not able to analyze that, then we cannot interpret those results properly, and we cannot modify this system. We cannot see the efficiency of this system. We cannot give the performance of the system. So, and use the maximum features or tools for analysis to reduce the time. A lot of features are there which we have to go, which can reduce our time also. So, thank you very much for your time and patience. Professor Modi.
No, sir.
Yes, because I want that some interactive session or something, they can ask me any that question. So that's why I made a little early this
Okay,
presentation.
sir. We will unmute the participants so they can raise their questions.
Yes.
Wait for 1 minute, sir.
Yes.
Hello. Hello.
Yes,
Hello.
sir.
Sir, good morning, sir. Sir, actually, I wanted to know whether we have a very simple book even for the polytechnic students also to learn the FEM courses.
Yes, a lot of books are there in market nowadays.
Yes, sir. Very
Where
simplest, very simplest. Even polytechnic person who comes to the second year from the engineering can also learn easily.
okay, so
Lateral entry.
yes, yes, one book from this NIT Ranchi. They have just now given one more book.
Sir,
uh, Dr. Kaushik has given. So this is simply problem, but if we are seeing the verification manuals and other things, they are
sir,
more simpler than these books are there because a lot of process according to the answers they have mentioned, each and every step they have mentioned.
sir.
So for polytechnic, if they will go for the verification manual, then it is very good for that.
Okay, sir.
No need to go for very high books or something, but the basics we should know.
Yes, sir. Thank you, sir.
Okay, thank you very much. Any other question is there? Organizers are there?
Sir, sorry to disturb you, sir. One more question I have, sir.
Ah, yes.
Sir, what is the difference between the online calculators that we have? If we type engineeringcalculators.com, we get different calculators wherein we have to just give the input and automatically the formula would be taken up and we get the output results. And the FEM solvers. Because mostly what I have checked is they both give the same kind of results.
Hmm.
So can we recommend online calculators as well instead of FEM also?
Ah, yes. Online calculators, if it is simple problems are there,
Yes, sir.
then yes, definitely you can use that. Should I on the camera or is
That's
okay?
fine for me, so no
That's
problem.
fine. Okay. So online calculators only for the simple assumptions are okay. If
Yes, sir.
you are having a complicated geometry or non-linearity or complicated things are there, then you cannot use them. But
Yes,
yes, mostly general problems, suppose cantilever is there, simply support, little small problems are there. But in that also we are not taking, we are just thinking that thickness is throughout the constant,
Yes,
metal
sir. Yes, sir.
properties
Yes,
are
yes.
throughout the
That is for
constant.
symmetricity only. Yes, sir.
Yeah, symmetricity, and this is so at that condition we can use. But if we are going for the real time problem, then we have to take care a lot. Yeah, we cannot say okay, whatever metal you are using. Suppose you are manufacturing a lot of metals. Okay,
Yes, sir. Yes, sir.
and each metal has the various range for that.
Yes, sir. Yes, sir.
And if you want to go for perfect kind of analysis, then we are taking the material and then we are characterizing it for different properties. Then we
Yes,
are using those property into our analysis.
yes, sir. Yes,
Okay,
sir.
so but this is a little higher kind of thing. For
Sir.
that, initially you can do with the standard things.
Okay, sir. Yes, sir. Thank you, sir. Sir.
Okay. I've given mostly the practical aspect which we are taking care when we are doing any kind of problems,
Yes,
which
sir.
is not mostly written in the books and not told, not standard procedures are there.
Yes, sir. Absolutely.
So at present also we are getting from ANSYS, we are doing some analysis, CFD analysis, and in that we have received the negative heat transfer coefficients.
Okay.
Okay, means heat transfer coefficient should be positive, but at certain geometry, certain place, certain flow, they are negative. So
Yes,
we
sir.
have raised this problem to ANSYS, and ANSYS has raised this problem to developer, and till now it has not been solved.
Sir.
Still, that why
Sir.
it is coming and what kind of problems are coming. We know that what physics is going on, but how to correct those things into the software. So like that problems comes and then we give the solution and other things. Then they correct those things into the software. Then they come back with problems. Okay.
Sir. Yes, sir. Okay, sir. Thank you, sir.
Okay. Should I leave or?
So, if any participant want to ask question, please, you all are unmuted, so you can ask the questions.
Today, are you doing this first time? Yes, try. Rinku, Rinku, are you ready? Can you present?
Manoj sir, it seems like there is no question from
Okay.
participant sides,
Okay.
so we can move ahead for the session.
So, yeah.
Okay. If there is no question, then so can I leave?
Sir, our session is planned up to 12, but if you have
Acha,
completed, then
okay.
we
Up
can.
to okay. Up to 12. I was thinking okay. So if
Okay.
any question is there, then I can give in detail, or should I give some more insights if they want? But I have not made any kind of so much presentation for that.
But you can give any more insight into the
More insight.
topic.
Okay, okay, okay. I can give the more insight into the some problems. As we are doing, but presently we are working on the projects which is the Aditya project which we are doing. So suppose if this how many have worked on the superconducting magnets? Or I think very few might have worked over that superconducting. So if we want to analyze, suppose some superconducting magnets are there, then we should know that which temperature it is going to be superconducting, because it will behave differently structurally and CFD wise at different timing zones. Yeah. So if we want to suppose one conductor is there, should I on the camera on so that I can explain something? Huh? Are you able to see me?
No, sir.
You are not. I have turned my camera on. Not able to see me. Yes, you have to do something.
No, sir. You are not visible.
From my side, I have made camera on. I can see myself, but I don't know. Maybe problem from.
Ekta ma'am, please mute your mic.
Okay. So suppose some superconductor Susan is there. If you want to design it, some noise is coming. Do you want to some settings so that you can see me and I can explain few things? Organizers.
Yes, sir. You just open your camera so we can see.
I have opened my camera. That's why I am
It's,
asking.
but it is not visible on screen, sir. Sir, we have already given a permission to present your camera. Hello, Manoj sir, am I audible? Hello. Manoj sir, hello. Manoj sir, you are not audible.
Hello,
Yes, sir. Now you are audible, and
Yes.
your camera is also visible.
video is also visible, na?
Yes.
Okay, okay. Some problem was there. So I was telling, suppose if you are going to design some superconducting magnets, okay, then this superconducting magnets has different kind of wires which are twisted in the nature. Okay, if you want to, are you audible to? I am
Yes, sir. You
audible.
are audible. Yes, sir. Yes, sir.
Oh, okay. So this magnet has the wire different kind of strands, and those strands are twisted in the nature. Yeah. So we are twisting each and every strand over the different strands. Then it is combined in a one case. Then this case is the again bounded into the magnet kind of thing. Suppose if you want to make circular magnet, then this case within that a lot of strands are there, and all the strands are not direct strands. They are twisted in the nature within that, and then again we are making the some circular coil. So what is the requirement into that? That all these strands should not break in between when we are twisting them. So we have to do analysis that it should not break when we are twisting them. Second requirement was that when we are giving any flow from this, because superconducting magnets they have to be properly cooled up to the temperature whatever is their transition temperature. Suppose neodymium titanium is there, then their transition temperature is 9 Kelvin. Okay, so 9 Kelvin is there, then we have to cool them less than that. Less than means at least up to 4 to 5 Kelvin. So we are using the liquid helium for that, 4 to 5 Kelvin. So that 3-4 Kelvin difference is always there for that. So these liquid helium has to be produced for that. So one more system is required for this superconducting magnets, and in high PR we have the cold box where we can get that. So from one side, if you want to cool that magnet, then it is going into that case. Strands are inside, and then it is going to the case. This low temperature fluid is going to the case. This low temperature, if directly we are giving, directly strands we are cooling, then it is easy to cool them. But why we are twisting them? Because we want to make the heat transfer more effectively. Otherwise, the flow will be just like as a laminar, and we will not remove that heat from the strands. If we are not giving the good heat transfer, then it will not be cooled properly. And so that we have to twist them, but twisting should be that helium should flow properly, and it should give good heat transfer. And if things are twisted in this turbulent kind of things, then pressure drop is very very high. So we have to check that there we want to give a balance optimization we have to do between all those things. Means it should be cooled also properly, and it's the pressure drop should also be less into that. Otherwise If pressure is too high, then we need very high source of high pressure, and we are getting the low. This means heat transfer also is compromised. So both things has to be optimized properly. So we have given the twist also. Around 60% we have filled that case with the strands, and 40% we have given to the flow. So CFD was very important at that case, by which we can get the flow pattern inside that, how much cooling capacity it is giving and how much pressure it is giving there. So both the things we have done the analysis, we have designed properly, and then from that means case having the strength, we have made the superconducting coil. So this is one kind of application we have done successfully. But when we have done CFD and this, at that time we have to see the electromagnetic. So we have coupled it with the electromagnetic analysis. When on that strands we have given the this current into that, then magnetic field generated into that. So the outer surface, the eddy currents were there and current were there. So magnetic fields is generated. So current and magnetic field, they have given the force on the case and on the strands also. So we have done the electromagnetic also, and from those electromagnetic analysis, at higher temperature, the resistance was very high because it was not the superconducting temperature. The resistance was high. So at that time, this I square R heating was very high. Means a lot of heat has been generated into that. So we have to do not only one case, that at the case of superconducting, how much heat is generated, how to take out the heat. We have to see when suppose it becomes the high temperature, go to high temperature. At that time, the resistance will be high, and whatever liquid is there, cryogenic liquid is there, it will evaporate suddenly, and it will has to flow out from the system. So what are the restrictions are there outside? We have to open all the valves and something so that the pressure should not go very high, and whatever pressure it is going up to that level, then we have to restrict it by the case should not be blast at that time. So we have to design that case as a just like as a pressure vessel kind of thing. So you can see only if we are designing only a small part for that, but we have to see everything. Means we have to use the pressure vessel codes also, we have to use the structural analysis also, we have to use the thermal analysis also, we have to do the CFD also. So in each case we have to see the combination of the physics or different kind of physics, but which physics is dominating mostly, we have to concentrate over that, and what properties are required in CFD, we have to concentrate over that, what metal properties are required, or if metal not suitable, then how to strengthen it with the minimum number of metal required. Because in cryogenic you can increase the quantity of material, but it will not be cooled down. So then it will be very difficult, and it will take a long time. Then practical aspects, a lot of money is invested in the cooling down time. So it will contract when it is cooled down, then again it will expand. So it should come to its original position. If it is not coming into the original position, means material selected, analysis done, design done, is not perfect here. So if we are going any analysis, then we have to see all the practical aspects. Second practical aspect, we have to see that it should be feasible for the manufacturing also, not only for the design and analysis. Design analysis, we can model any kind of feature, and those features can be used, but if it is not possible in fabrication, then it is very difficult. Suppose we have taken very high material, very low material, then a lot of problems will come. Suppose in heater, whatever we have done, we have made the cryostat. The cryostat thickness came, because it is 30 meter by 30 meter, the thickness came around 70 to 80 mm of the plate, and from that plate we have to make everything. So many places we have used the stiffeners, but at some part we cannot use the stiffeners also, and we cannot reduce the thickness also due to the very high pressure requirements. Then we have developed the procedure for welding, that how to weld for 60 mm, 70 mm thick plates. It should be fully penetrating welding this. But again, the residual stress analysis we have to do, because whenever we are welding into that kind of things, then we have to see the stress remained after the fabrication. So for those stresses, we can take out from different kind of different procedures, but still the stresses were there. How much it can take, and what effects it will give further. So a lot of practical things has to be considered when we are doing the analysis. So analysis, when some person is doing analysis, he should not only know the only design and the software. He should know the fabrication procedure also. He should know how to join them, what kind of procedure for joining is required, how to install them, and how to commission. Means this designer and analyst has to know from very basics up to the last of the product. Otherwise, he cannot become very good designer or analysis. So only analysis, doing analysis is not one of the part for that design person. So we have to be very metal also. We should know that which metal we are choosing, how much it will affect. So all the different kind of physics. And in our place, if we are doing mechanical things, then we should know the nearby electrical aspects. Also, we should know the this computing aspects also, that how the things wires will come into this, and then they will take the data. In our cryogenics, a lot of wires or sensors are there which we have to put nearby to measure the temperature. Suppose thermocouples are there which we are to put it, but all those wires will take the heat away, or outside heat can be penetrate up to the last point through these wires only. So what should do? Otherwise, this different kind of heat load will come. It means we should know the wires also, how they are insulated, how we have to keep in there, so that we are doing anchoring of the wires, so that at last point it should not propagate the heat also, and it should not give the wrong results. So designer has to see all those aspects in practically, and then they have to combine it practically, and then do the analysis. Not only simple analysis has been done and it is over. So very critical things are failed due to not from this kind of analysis. I am giving one more example, practical example, which was lost to the one company, very heavy loss given to the company. We have designed something here in IPR, and we have given them for further, because they were expert in that. So we have told them to fabricate some liquid pumps. But they have done, they have made all those pumps because they were expert in that pump, but due to some aspects, they have used one more material. So one more metal they have used. They thought, okay, both are behaving almost similar, so they have used it. But the gap between the pump and the body is very in micron level, and these two metals have the different kind of thermal expansion. When they have started it, and cost was one pump cost was approximately 30 lakhs. So when they have started the pump, they have broken that pump. So they have manufactured three pumps, then broken all the three pumps. They thought, okay, some problem was there, that's why it is. But later on, we have seen that they have used, instead of one material, they have used one more material which has different coefficient of thermal expansion. But they have not analyzed it properly, that material. So due to that, the heavy loss was there. So these are kind of practical aspects. We are facing a lot of things. So it is not easy to do the only design and analysis part. So whenever my suggestion is, whenever you are going to industry or you are giving consultation to any industry or something, then you have to see all the practical things, how they are manufacturing, how they are joining, and how they are installing the things. So these are some more insights for the analysis part when we are doing this. Not only analysis, this is the concept from beginning to end. I think I have given something more to them. If there is a question, otherwise we can leave.
Participants, you can ask the questions. Any questions?
I think there is no question.
I think yes. Nobody
Yes,
is.
and if
I
they
think that,
want, they can send me the questions on my mobile numbers and my
sir, there
email
is one
through
question.
you.
There is one question in the chat box.
Okay,
What is the
let me
difference
check.
between the, yeah,
Tell.
what,
I'm not
yeah, what
able.
is the, shall I say it, sir?
Yes, yes, no problem.
Okay, yeah, yeah. What is the difference between the online calculators and the FEM solvers? Do they provide the
That,
same reliable and valid results?
I have given the answer to that.
Okay, actually, I was, my net was not there, so I was, okay, okay, sir. Okay, so I think there are no questions. Thank you so much, sir, for your resourceful lecture. The detailed design aspect report analysis and answers was discussed very nicely. Overall, the session was very fruitful. And thank you so much, sir, once again on behalf of FDP team and Government Engineering College Bharuch for sparing your valuable time. Thank you so much, sir, for our invitation.
Okay, thank you very
Good
much.
morning, madam. At what time do we have the exam, madam, today?
Yes, sir, that is what I am going to say now.
Okay.
Sir, the link for the test will be posted in the chat box of MS Teams at 3 p.m. as well as it will be posted in WhatsApp also. It will be at, yeah, at 3 p.m. it will be scheduled, and there will be 50 questions of 2 marks each. So the paper is of 100 marks. The test is 100 marks, objective type only.
Okay.
And it is compulsory for all of you to score 60 marks to get Atal certificate.
Okay, madam.
So yes, yes. So the link you will be able to find in WhatsApp, also in the chat box of MS Teams.
Okay, madam. Yeah, thank you, madam.
Yeah, yeah, yeah. Okay, so participants, we will meet at 1 p.m.
Mana? Hah? Kayak taruh dulu udah nih cuma mana? Ini entah sasti dulu pun jangan makan tahu. Ambil itu, taruh buka. Dah. હમ 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 તારે તો ઓનલાઈન જોઈ લે એટલે તારા સાહેબને કે ઓનલાઈન મળતી જશે મંગાઈ લઈએ હા ચાલો હું સાહેબને પડે ચાલો તમારું હા એટલે પેલું પેમેન્ટ અત્યાર સુધી તમને ખાલી બિલ જ જોઈએ ને એટલે બિલ જે ઓનલાઈન નો આવે તે જ રહે એ તો ઓર્ડર આપી કોલેજના નામે મંગાવે હા બાકી હું મારા બાકી તો જેનું એકાઉન્ટ હોય ને જે એકાઉન્ટમાં દાખલા હું મંગાવું મારા નામથી આવે એમાં અંદર હોય ઓપ્શન ઓર્ડર ટુ એવી રીતના જોઈ લો ચાલો
બ્લેક જ છે ને આગળ ટૂંકમાં સિલ્વર જેવો
Deepa ma'am.
Hello, Doctor.
Yes.
Dr. Vijay Kumar Dalla is with us.
Yeah.
Kindly start
Yeah.
the session.
Okay.
Welcome, sir.
Thank you, sir. Good afternoon to all the participants and Dr. Vijay Bharuch, sir. Dr. Kumar Dalla, sir, is Assistant Professor in Department of Mechanical Engineering. His area of research is robotics, dynamics, and control. At present, he is guiding 4 PhD students. He has published 14 research papers in reputed international journals and conferences. He is the lifetime member of Machines and Mechanism and Robotics Society. He has received MHRD fellowships for his persuasion of post-graduation and doctorate degrees. He has given many guest lectures in more than 35 institutes in the country, and he has conducted NPIU initiative TechWhip sponsored 150 hours training session on robotics and automation at the host institutions of different domains. And we are very much grateful, sir, that we are having you as the expert today. I invite you, sir, to start with the session.
Yeah, thank you, madam. Thank you very much. And
Welcome,
thank you,
sir.
dear coordinator, Thank you, dear coordinator, Modi sir, for giving me this opportunity to interact with the participants. My today's topic is FEM in robotics. So, which just I'm going to start. Give me a few minutes only. Just there is actually there were connection problem and also power was not there. That's why. Yeah, just give me 2 minutes. Ma'am, which type of participants means whether they are the faculty members or
Sir, they are faculty members
Yes,
from
sir.
all over India, sir.
okay. And how many participants from the own institute?
So from my institute, there are 10 participants.
Okay, okay. Actually, sir, I am not at NIT Jamshedpur. My vacation is going on. So I am at my in-laws' home. That's why, yeah. Yeah.
मैंने ना गूगल स्कॉलर पे अपनी प्रोफाइल बनाई उसमें आता है ना सेलेक्ट ऑप्शन तो है ना उनको समझ ही नहीं आ रहा कि अपना जैसे प्रोफाइल बनाया ना बहुत सारे और 5,000 साइटेशन
Sir, are you facing any
Yeah.
problem? Sir, your screen is visible now.
Yeah, sorry for the inconvenience. Actually, I'm not at the campus of NIT Jamshedpur, so even I'm dealing with a different system computer. It is my own, not my own computer, so this is problem. Yeah. So thank you for the invitation. What I have done, FEM in the robotics system that I am going to expose. Firstly, I am Dr. Vijay Kumar. I have done my PhD, my PhD, in which I also used artificial intelligence in robotics like a genetic algorithm for optimizing the trajectory, and I have used the software bond graph, the technique bond graph technique, in which I have used the numerical methods, Dunge Kutta method. So whatever we get means get solutions of in the robotics system like analyzing a robot and getting the trajectory, avoiding obstacles. All I have done with the help of software. The software name is Symbols. Okay. And regarding this, later, my student, my MTech student, he is now with IIT Jodhpur. He worked in FEM in the robotics using SolidWorks, using ANSYS, SolidWorks for preparing 3D model and extracting data and analyzing the system. For that, ANSYS is used. Okay. So, I have divided my lectures into two parts. First, the basics of FEM used in robotics. Then I will go to the software exposure. The software name is RoboAnalyze. See the motion of virtual robots like kinematics and the dynamics of a robot. So in which in this way I have divided my lecture in two parts. So please bear with me. And regarding this finite element method, so obviously it is the fifth day, last day. So you all are aware about the basics of FEM. But what about the applications in different domains? Can we use it? In the case of robotics, where accuracy matters. Like suppose a robot is drilling on the wall, or robot is doing some other critical work like inspecting a pipeline, inspecting a pipeline. So in that case, the robot needs to go inside the pipeline. So suppose for surgical application, you might be knowing a robot can go inside our stomach, can take peaks, and also can do surgery. So in that case, is it possible if you use approximation method, numerical methods like FEM, where accuracy is concerned? Okay, so my answer is accurate answer. Answer means accurate position and orientation of the robot. So in that case, we can minimize. We cannot avoid completely, but definitely we can minimize the error. And what is that error? The error between the reference velocity and the actual velocity. Means the deviation from the actual location. Okay. So coming back to this FEM, the finite element method is a numerical technique for finding approximate solution to boundary value problems for partial differential equation. In simple terms, FEM is a method for dividing of a very intricate problem into small elements that can be solved in relation to each other. It is useful for problems with complicated geometries, loadings, and material properties where analytical solutions cannot be obtained. In many cases, in robotics also, for a complex kind of robot like multiple degrees of freedom and having 3 degrees of uh, 3 dimensional, in that case, it's very difficult to analyze. So in that case, we can obviously opt the finite element method. And regarding history of FEM, so I think these I no need to discuss all are aware, but still the finite element analysis was first developed in 1943 by R. Cohen, who utilized the Ritz method of numerical analysis and minimization of variational calculus. A paper published in 1956 by M.J. Turner, R.W. Clough, S.C. Martin, and L.J. Shaw established a broader definition of numerical analysis. By the early 70s, FEM was limited to expensive mainframe computers generally owned by aeronautics, automotive, defense, and numerical industries. This subject is now being taught in UG and PG courses. Nowadays, it is interdisciplinary, and we need to gain knowledge and can be utilized in mechanical domain, civil domain, mainly in mechanical for analyzing the beams that in that case we can use. Okay. So working of finite element method, it uses a complex system of points called nodes which make a grid called a maze. This maze is programmed to contain the material and the structural properties which define how the structure will react to certain loading conditions. Nodes are assigned at a certain density throughout the material depending on the anticipated stress level of a particular area. Regions which will receive large amount of stress usually have a higher node density than those which experience little or no stress. And regarding types of finite element method, finite elements, so it may be either 1D, 2D elements, and 3D elements. Mazing in FEM, maze is your way of communicating geometry to the solver. The accuracy of the system is on the quality of the maze. The better the maze looks, the more accurate the solution. Okay. So it depends how many nodes, means better to divide it in the number of sections, and that depends person to person. Meshing also depends person to person. As a result, also we get the solutions. The solutions means which is more closer to the exact solution. And the FEM nodes used for meshing. So like 2 nodes, linear, 3 nodes, quadratic, 4 node, 2B. That is in the case of beam truss elements. For triangular elements, 3 nodes, 6 nodes, 10 nodes are used. Okay. The beam element used for meshing, the beam elements typically fall into 2 categories, which is able to transmit moments or able to transmit moment, or sorry, not able to transmit moment. Okay, one is able to whether it is able to transmit, and another is whether it is able to transmit or not able to transmit. I'm moving it because all these are, I assuming, have already been covered. And what are the benefits of FEM in simulation? Because we are dealing this uh, in modeling and the simulation, so you might be knowing about the difference between modeling and simulation. Modeling is what? The representation of any physical system, either in terms of mathematical modeling, or in terms of a block diagram, or in terms of graphical representation. And simulation is what? Is the way of validation of the proposed model. Okay. So through the simulation also we can predict the behavior of the system.
Sorry, sir.
Behavior.
Sir, sorry, sir,
Yeah.
sir, sorry to interrupt you. But your presentation is not visible, sir.
Not visible?
No, no, sir.
Okay, okay. But I have shared, ma'am. Just
No,
one.
yeah, yeah.
It's still not visible.
No, sir, still not visible.
Oh, just one. But I have shared.
Yeah, yes, it is now visible.
Yeah. Now, but they also have shared it. I don't know why.
Yes, the presentation is visible, sir.
Visible, na? Okay.
Yes, yes, sir.
So, yeah. What I was saying, the difference between modeling and a simulation and how to validate the proposed model. So, simulation is one of the way to validation in virtual mode. For the actual, then we can go for the actual validation means experimental. But this is also one of the way to validate the system. So regarding benefits of FEM in simulation, the reduce the testing and redesign costs, thereby shortening the product development time. This is the beauty of simulation. If you directly do some experimental work for the validation purpose, so we need space for that, we need time for that, we need to afford the setup cost, and suppose failure occurs, then it becomes difficult. It becomes expensive. Identify issues in design before tooling is committed. Okay, if there are some issues in designing, like designing a motor, so how much power a motor is required? Okay, and how whether the link of the manipulator is able to sustain, able to bear the applied load. Okay, or you can say the reactions of the manipulator, whether it is able to cope up or not. So that kind of things easily we can identify. Refine components before dependency to other components to avoid changing. Optimize performance before prototyping. Is there any possibilities to optimize? In the case of robotics, optimizing means whether we are able to save the fuel required to run the motor required. Suppose in the case of satellite, for the service life of the satellite, whether we are able to optimize the path. Okay, sometimes intermediate path is not required. In that case, start point or goal point matters. Okay, so can we optimize? That I have done by using genetic algorithm, and I also published in paper. One can access that. Next, discover design problems before litigation. Okay. Before the building of actual model prototype, we can discover the various problems associated with the manipulator. So basic steps implemented in FEM. So you all are aware, but again I'm repeating this. Discretization first, very first. Selection of approximation of functions. Formation of elemental stiffness function. Formation of total stiffness function matrix. Firstly, the total system, total manipulator is divided into small sections. So we need to formulate stiffness for each and individual section or element. Then we need to integrate so that we can get a total stiffness matrix. Then formation of element loading matrix. Then again, it is for total loading matrix, formation of overall equilibrium equation. Then implementation of boundary conditions. In the case of robotics, we can find out the boundary conditions and apply like our trajectory means we need to for the trajectory is a time dependent equations. So in many cases we need to use the certain trajectory like a B-spline curve, Bezier curve. So for that we need to select the control points. Okay. So in that we need to know the boundary conditions, lower bound and the upper bounds. That is one kind of limitations. The system. Then calculation of unknown nodal displacements. Okay. Suppose there is a deflections. We are going to study the deflections in the link of the manipulator. However, generally we study about the rigid bodies, but in the actual cases, rigid bodies may not be applied in many cases. The flexible manipulator is required. So in that case, some we will be knowing about displacements of some nodes, but obviously some cases, some displacements we need to calculate. Then finally, calculation of stresses and strength. Okay, so just like a beam, we can know about stresses developed in the manipulator and the strengths as a result in developed in the manipulator. Because a robot is not only limited to only for one application. It can be used in very complex environments like dealing very hot object, very cold object. So there may be sudden changes in the its stresses and strength. It may go in the space. It may assemble the parts. It can weld. If you see, like in Tata Motors, we have visited. So there are thousands of weldings required in the car. Okay. So whether our manipulator is able to cope up with that environment. Okay. So that analysis we can do very easily with the with using FEM. And these are the list of phases involved in FEM, like pre-processing, post-processing, and regarding the advantages of FEM, specific numerical result is obtained for a specific problem. Experience and the judgment are needed in order to construct a good finite element model. A powerful computer and a reliable FEM software are essential. Computer should powerful or its analysis takes 2 days, 3 days, 4 days, even 1 week. Okay, but using a powerful high-end system, we can avoid this kind of difficulty. Input and output data may be large and tedious to prepare and interpret. If you see the matrix we get while analyzing the system, the big matrix. So dealing with that is very difficult. Numerical errors such as the limitation of the number of significant digits rounding off occur very often. Next, application of FEM in design of robot. So, in the structural analysis of manipulator consists of linear and non-linear models. Linear models use simple parameters and assume that the material is not elastically deformed. Non-linear models consist of stressing the material parts. It's a elastic capacity. The stresses in the material then vary with the amount of deformation. In a vibrational analysis, it is used to test a manipulator base against random vibrations, shock, and impact. So in robotics, from where the vibrations comes, means what is the origin of the vibration. While suppose welding robot is there are a number of robots aligned to weld the car parts. So while dealing with the environment, and what is the environment in that case? The car body. While dealing, while welding, so whatever the vibrations will be, that will be transferred from the end effector, like we have wrist and fingers. So these fingers are end effector in the case of robotics. In the case of robotics, up to wrist is considered the part of robot. Okay. So there will be contact between the end effector and the goal point, the car body. So dealing with that, the vibrations will be transferred from the end effector of the manipulator to the base of the robot. Okay, so that can be observed in the manipulator's behavior in the trajectories, there may be deviations in the trajectories. Suppose a robot is not grounded. In that case, what will be? And suppose it robot is grounded, means a robot is a ground robot, and a robot also may be of a mobile robot, a space robot. In that case, the whatever vibrations will not be absorbed by the ground. Okay, so that will ultimately affect the trajectories of the robot, the motion of the manipulator. That's why vibrational analysis is required. And each of these incidences may act on the natural vibrational frequency of the material, which in turn may cause resonance and a subsequent failure. Okay. So if a vibration will not be absorbed by the ground, so there will be obviously error in the trajectories, and if there will be more vibrations, so there may be chances of damaging of the manipulator. So that's why the analysis is required. Our manipulator means the mechanical structure of the robot, whether can sustain the vibrations coming from the environment or not. Okay. The fatigue analysis helps designer to predict the life of a robot structure by showing the effects of cycling loading on the specimen. Yeah, please give me 1 minute break. I'm coming back. Please allow me. Then I will continue.
હેલો ઢીલા સર, તમારો અવાજ નથી આવતો. યોર વોઇસ ઇઝ નોટ ઓડિબલ. હેલો હેલો Birla sir. Hello. Hello.
Yeah, I came back. Sorry for the disturbance.
So now it is audible, sir.
Yeah, yeah. So regarding fatigue analysis, in the case of robotics, so fatigue analysis, you all are aware that fatigue analysis helps designer to predict the life of a robot structure by showing the effect of cycling loading on the specimen. So while dealing with the objects, means capturing the object, the manipulator feels vibration, okay, and that vibrations can be of the cycling, loading, unloading, loading, unloading. A robot can
Sir, again you are not audible. Birla sir, you are not audible.
Participants, please bear with us. I think there is some net issue with the expert. We will just connect you as soon as he is with us. Please bear with us for some time.
Hello, hello.
Yes, sir. Yes, you are audible now.
Yeah, suddenly I was disconnected.
Yeah, yeah.
Yeah. So I was discussing fatigue analysis in the manipulator. So in such analysis can show the areas where crack propagation is most likely to occur. You might be knowing the crack in the body is very dangerous. Okay, it is one kind of defect, and while dealing with the object, there may be failure in the manipulator. Failure due to fatigue may also show the damage tolerance of the robotic structure. Okay. And now FEM analysis of soft robot finger. This is done by my MTech student. I guided him. So firstly, the mathematical modeling of a soft flexible finger is done. So what is the finger in that case? Robotics, the fingers are the hand effector. Okay, and the soft flexible fingers, like आप देखेंगे जैसे the in many cases the hand effectors either may be very rigid, it may be very soft, it may be very flexible. Dealing with the delicate objects, the hand effector should also be softer, or it may damage to the object, and that object may be precious. In many cases, that object may be precious. So, mathematical modeling is done taking into consideration an element of a cylindrical, soft, flexible finger. The relation of equivalent force is represented as follows. The stress, which is normal, transverse stress on the soft flexible particle is given by sigma is equal to F divided by S. F and S are contact transverse force and the contact surface area respectively. Normal contact area pressure acting on the soft robot particle is expressed as by P is equal to F by S. Okay. So obviously, you might be knowing the difference about the stress and the pressure. Our PhD admission interview was going on. Today it is completed. I was also the member of the admission committee. We asked many times this kind of questions, and some were able to answer, but most of the participants were unable to answer. Like the difference between the stress and the pressure. The same is involved in the case of robotics also. When a minute transverse compressive force is made functional to the soft flexible particle, the radius of soft finger all along y-axis reducing. But alternatively, the width of contact maximizes. Yeah. The partial transformation in the semi-radius all along y-axis of flexible soft finger particle is expressed as the transverse compressive strain. Okay. Then from that stress we found the strain. Then by utilizing Young's modulus of elasticity, the relation of force acting on the soft flexible particle is represented as by this. F is equal to E, then del R divided by R. Geometric analysis of a soft robot finger. During effective power grasping, holding and grasping, these are the two major concerns in the gripper. Okay. So grasping, holding, we need to suppose a robot is in space. Generally, robot goes in the space and capture some tumbling object, or you can say the parts of satellite which are not in use. So to avoid a traffic problem in the space, the robot is sent, and the robot captures and decomposes the unavoided obstacles, the parts. So in that case, grasping involved a number of numerous contact surface area points exist among the targeted object and the contact surface of robot soft finger. This results maximization of load bearing capacity of power grasping system, and due to enveloping nature, it is highly stable. While capturing the objects, more number of contact points are required, and the load bearing capacity depends on that number of contact points. If contact points will be more, then grasping will be better. If contact point will be lesser, then obviously the grasping power will be less. In case of rigid finger, the twisting of soft finger at contact surface point is negligible. So far, grasping of target, the large amount of normal force is required. But a soft finger has property of deformation during grasping. But this increases the contact area. Yeah. This is the geometry of the soft robot of the finger made by my student. This is regarding analysis involved by using a finite element method. So FEA is mathematical model utilized to solve the complicated. So this already we have discussed. So further no need to discuss. Yeah. Regarding this finite element iterations, the most popular FE software is ANSYS. which is used to originate a two-dimensional FE model. The description of the modeling system used for system is Pentium. These are very basic. So, discuss. What are the assumptions we were taken? Remember, while analyzing the system, while analyzing the in the system, either it may be robotics or something else. So always we need to take assumptions. And suppose you are going to publish a paper, and if you don't put any assumptions, and obviously assumptions simplify the analysis of the system. So if you don't consider assumptions, so many times papers are rejected. So what are the assumptions we have taken? The soft materials were assumed to be incompressible, homogeneous, non-linear elastic, and isotropic in nature. Two-dimensional plane strain conditions were applied for the simulation. Okay, means third axis is not considered in the study. And regarding these first assumptions, incompressible, homogeneous, non-linear elastics. So generally the nature of robotics is non-linear. That's why controlling the non-linear body is very difficult. And for that, we can use either the conventional controllers like PID, PD, PI controller. And next, the 3D contact model. This is the plane strain analysis was performed by selecting 182 constituent elements in the ANSYS APDL, illustrated by the 4 locations, and each node has 2 degrees of freedom. In the robotics, or in general, a body in space will have 6 degrees of freedom. 3 for rotation, 3 for translation. In the robotics, each active joint is considered as 1 degree of freedom. So here we are talking about 2 degrees of freedom. The selected item has properties of plasticity, hyperelasticity, compression, toughness, maximum deviation, and maximum strength. Meshing by FEM. So after the first meshing, the size of material is reduced by the contact area as shown in the figure. Refinement in the contact surface area is done in a manner that the contact surface area must not be exaggerated. The deformation by FEM, the ANSYS internally manages the increased load to get it integrated the solution. It continues until an integrated solution for the loading applied. Soft finger rotation is calculated at the orientation point, the node corresponding to the upper part, and the connection width was measured depending upon the numerous elements encountered by the solid slide. So this is regarding stress analysis we have done, and this is regarding deformation FA results of finger. So it says the FA results of finger and the Ogden finger models, constraints and the test results. So our main focus is here regarding the nature of deformation. 0.02% deviation is noted between FE results of fingerprint model of neoprene and Ogden manufacturer and the experiments result. So in this way, we have done the deformation analysis in the manipulator. So this part I am going to conclude. Then a little bit I will give exposure of another software so that motion of the robots can be fed. So what is the summary of this task? A little task is done with the help of my student. The variation of contact with and the deformation with applied normal force ranges from 0 to 100 Newton were determined. Inclined tests were conducted for each soft finger against target material. It is to determine the frictional coefficient between them. Numerical simulation was done for the semi-cylindrical soft finger and successfully validated with experimental results. Numerical simulation was done for semi-cylindrical. Yeah, this is done. Now, the another part I am giving exposure that is related to the software. I will complete it quickly. This what I have discussed, that is for analysis of the deformations, stresses, strains involved in the manipulator. Next to the motion part, like kinematics and the dynamics, that can be visualized by using this software Robo Analyzer. And before that, I wanted to say regarding that, if one is interested to find the published paper of mine related to FEM in the robotics, so one can search my name in the Google. Then one can get my biodata, all informations, email ID, mobile numbers, and publications. And another thing, from the Google Scholar, this is a finite element analysis of fundamental deformation of robot soft finger. this can be accessed. If one is interested, then one can go through this paper. And regarding the software, which may be very useful, the robo analyzer. This software, the robo analyzer is a 3D model based software. So how to download the software? So one can go in this page and can download the software, the latest version. Okay. Now coming to the software, and this software is open source, not commercial. So especially the mechanical engineering students, or it is also for faculty members, those are interested in the robotics field, are simply for showing the motions, giving example of kinematics and the dynamics. So this is the best software in which the motion can be visualized by either 3D model or by the graphical presentation. Okay. So 3D model, here these are the inbuilt robots. So from 1 degree of freedom to 7 degrees of freedom, robot we can access. And these are the types of robots, like the types of joints, prismatic, either prismatic or revolute. So you can see if there are 2P means 2 prismatic, 2R, 2 revolute, PR prismatic and revolute. RP means first joint is revolute and second joint is prismatic. Suppose we want to access 5 degrees of freedom robot, and also in 5 degrees of freedom there are 3 inbuilt robots. Let us load this one. So it is the 3D model of the robot, and what we wanted to know here, the motion we want to visualize. The earlier what I have discussed, that is analysis of the, you can say, stresses, strains developed in the manipulator. But that is ultimately used for providing motions to the manipulator. So that motions I'm going to study, I'm going to talk. So for that, we need to know forward kinematics, we need to know inverse kinematics. So in forward kinematics, what we need to find out? In forward kinematics, we want to know about the end effector positions for the given joint variables, joint angles. But in the case of inverse kinematics, we want to know the various set of joint variables. What are the joint angles to reach the certain goal point? मान लीजिए आपको वेल्डिंग करना है, मान लीजिए आपको कुछ पाइप के अंदर इंस्पेक्शन करना है, आपको मीन्स रोबोट. So for that we need to have multiple degrees of freedom, means number of joints. So what will be values of that joints? That can be found by the inverse kinematics. Okay. So I am doing here now. The time I have given 1 second. It can be increased. It is of software age, not commercial till now. So anyone can access this software. Yeah. Number of steps I have given. Then I'm clicking the forward kinematics. So see, the analysis is complete. Analysis is complete means equations are developed. Then now we can see the motion by playing this animation. So see the motion of the manipulator of the robot. और यही robot का, for example, we have analyzed how much payload it can bear, it can cope up. So that analysis can be done by using FEM. And here also the analysis is done by using numerical methods. By using numerical methods. So see, regarding this motion, it is the trajectory of the robot. Trajectory of the robot. So this motion is visualized by seeing. Also, this can be visualized by this graph. Our main focus is to know about the positions of end effectors. So that is found how the nature of end effector motion, from where it is started, whether it is going up in the positive or negative directions, like above zero values or below, and where it is, what is the maximum values of the end effectors, means the position of the end effectors can be found from this graph. Okay. So as I told, there are two ways to know, to visualize the motion of the manipulator. One is by the 3D model and the other is by graphical representation of the result. And inverse kinematics, what we find out? We find out the joint angles. So for the given end effector positions, x is equal to this much, 0.35 meter, y is equal to 0.1 meter, z is equal to 0.5 meter. So what are the various set of joint variable? Why I am saying a set? Because this robot has 6 degrees of freedom. So if I click this inverse kinematics to see how many solutions, number of solutions in this software, only 8 solutions are displayed. So 8 solutions we have right now. Okay. Means, what is the meaning of this? 8 solutions we have. The positions are fixed. The end effector positions are fixed. Like आपको जैसे रोबोट को बाय द वे आपको नट को टाइट करना है. Nut को टाइट करना है, so there will be some specific locations, and it doesn't matter which path is followed, but location matters. Okay, so which path is followed, that is determined by the these joint variables. The joint variables. Okay. So suppose I take values of the solution 1, then see what is happening. If I take solution 1, then my configuration of the robot means how it looks like, means what is the position and the orientation of the manipulator. So by taking these values of solution 1, it looks like this, and suppose I am taking values of solution 5, then see, is there any changes? Obviously there are changes, and you just observe the changes. Solution 2, see, solution 7. So various configurations we can get by loading the various set of joint variables. So this inverse kinematics is also done. However, you will be saying what is the connection of FEM with this? Yeah, I accept that there is not a direct connection because, but we can connect this analysis of the manipulator is done, can be done by FEM, and how much a payload is able to bear, that can be done by FEM. Whatever analysis is done here, like after clicking see here, analysis is complete, is by using numerical methods, approximation methods. So FEM is also based on approximation method. Okay. One more thing I want to give exposure, that is very good things one can enjoy. Faculty members use this software for the better visualization of the robot. If you don't have real robots, mainly in that case, it is very useful. Yeah. This robot, by default, this ABI, this is the model name of this robot is coming to display here. You can select various robots, like suppose I am going to select this Kuka made in India, this robot. I am going to load. Yeah, it is being loaded. Yeah. So we can control this robot either by the controlling joints or by controlling end effect. So by controlling joints, we can identify some. In some cases, it is very difficult to identify which one is joint 1, 2, 3. So in that case, like this is easily one can identify the joint 2, joint 3, joint 4, joint 5, joint 6. In this way, we can control the joints. Now, coming to the home position, means ये home position में आ गया robot. Now, through the Cartesian control, we are going to control the end effector. And suppose I am increasing the increment. This I am doing. Okay. Now, for doing manipulation, a certain path is required. So how to how to trace the certain path. So this I'm going to do. I am clicking. This is the limit of so better. Yeah, better to go. Yeah, in this way, yeah, taking too much time. Okay, once again, let us. This I'm putting here 3. I'm just putting 2. Okay, and see the traces in the, you can say, workspace in the screen. I'm clicking X the minus icon. Our purpose is to make a rectangular, or you can say to follow the path of rectangular. Okay, we need to now go this. In this way, we can close the circuit. Close the circuit means we will be able to get the rectangular path by closing the circuit. Yeah. Yeah, in this way, either we can control our manipulator through the joints or through the AND effectors, means Cartesian control. So in this way, I try to give some things what I could do to the best of my efforts. I try to give something, I try to expose, I try to share my knowledge with the participants. However, I was totally not focused with the FEM in robotics because there is some technical problems. But I tried to give something that you can enjoy and you can take it as reference for the visualization of, suppose if you want to visualize the motions of the manipulator, then obviously you can choose this software, and it is open source, so anyone can access without any difficulty. So with this, I would like to say thank you. But before that, you can interact with me. But I would like thanks to coordinator Dr. Modi and your institute and the dear participants. Thank you for bearing me. If you want to interact with me, so please you can interact. You're welcome. I have done from my side.
Dear participants, your mic is unmute. Please ask the questions if you have.
The software name is Ruben Ledger. For FEM analysis, one can use ANSYS. Yeah, if you don't want to interact right now,
Okay.
so yeah.
Yes, sir. I hope the participants will interact with you if they have any questions through email.
Yeah,
Thank you.
definitely.
Yeah. Yeah.
You can interact with me if you have any whether personal or professional problems. If you want to discuss with me, so you are always welcome. I have also my YouTube channel, Vijay Dalla. If you search in YouTube, so you will find me. I am also in Facebook. Also, you can connect with me. There are many cases where we can interact, and our interaction is required. Not only from your side, I may also require to interact with you. So without any hesitation, you can interact with me anytime, whenever you want. Yeah, ma'am.
Yeah, thank you so much, sir. Thank you for the informative session and also for all the resourceful information you have shared in this session. You also delivered this in session with full enthusiasm. Thank you so much, sir. And we are very graceful to have you. And on behalf of our team from GEC Bharuch, I thank you so much, sir.
Yeah. Thank you, ma'am.
Yes, sir. Thank you.
Yeah. Thank you.
Dear participants, please be connected at 3 p.m. The link will be shared in WhatsApp and MS Teams chat box also. The session, this test will be or quiz will be for 1 hour. 100 marks test will be there with 50 questions, each of 2 marks. So please be connected at 3 p.m. A very good evening to our honorable chief guest, Dr. Sachin Parikh sir, Joint Director, Commissionerate of Technical Education, Government of Gujarat. Respected Dr. Sanjay Joshi sir, Principal, Government Engineering College, Bharuch. Respected Dr. Ratnesh Shukla sir, Head, Mechanical Engineering Department, Government Engineering College, Bharuch. All respected head of departments from GEC Bharuch, dear faculties and dear participants. I, Deepa,
Ma'am,
on behalf of
ma'am,
yes, sir.
we are waiting for Sachin sir.
Okay, so just tell me when we shall start, sir.
Sure, ma'am.
अरे
Okay.
मैडम ओ दीपा मैडम हेलो एम
Yes,
आई
sir. Yes, sir.
हाँ
Yes, sir. You are audible.
हाँ हाँ वी शुड से वी आर वेटिंग फॉर सचिन परीख सर
Okay. 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 Yes, sir.
हाँ
Yes, Deepa ma'am.
Yes, sir.
Our chief guest, Dr. Sachin Parekh sir, is with us.
Okay, sir.
You may start, ma'am.
Okay, okay, sir. A very good evening to our honorable chief guest, Dr. Sachin Parikh, sir, Joint Director, Commissionerate of Technical Education, Government of Gujarat, respected Dr. Sanjay Joshi, sir, Principal, Government Engineering College, Bharuch, respected Dr. Ratish Shukla, sir, Head, Mechanical Engineering Department, Government Engineering College, Bharuch, all respected head of departments from GEC Bharuch, dear faculties and dear participants. I, Deepa Pandey, on behalf of organizing team Mechanical Engineering Department, GEC Bharuch, welcome you all to the valedictory function of AICT sponsored online Atal Faculty Development Program on elements of FEM. Before we proceed with the program, I would request our FDP coordinator, Professor Ashish Modi sir, to please give the overview about this 1 week program.
Thank you, madam. Respected Dr. Sachin Parekh sir, Joint Director, City, Gujarat State. Respected Principal sir, Dr. S.R. Joshi. Respected Head of the Department, Dr. R.K. Shukla sir. Level based to make this FDP fruitful for every participant. From the day of making proposal of this FDP, I am thankful to my departmental FDP team for planning and execution. I am sincerely thankful to Dr. S.R. Joshi sir to motivate us for proposing and organizing such kind of FDP and showing trust on us. For FDP, we got immense support from all the participants, AICT Atal Academy New Delhi, experts from various institutes and national organizations, and how can I forget my departmental faculty members from GEC Bharuch, especially thanks to Dr. R.K. Shukla sir, Dr. H.K. Solanki sir, Professor Vimal Patel sir, Professor Vasant Patel sir, Professor Ashfaq Sheikh sir, Professor B.C. Pathak sir, and Professor Deepa Pandey madam for their unconditional support. I would like to bring in kind notice to our honorable chief guest, Dr. Sachin Parikh sir, that our FDP become highly popular in terms of participants in registration. Total 200 participants were registered, and from that 180 were selected. We got participants from every state all over the India. There were 14 sessions excluding inaugural and valedictory ceremony. Dr. Rupesh Shah sir, Associate Dean Academics from SPNIT Surat, has graced our inaugural function as a chief guest and a session expert for the first session. Eminent speaker and subject experts, Dr. H.B. Mehta sir from SPNIT Surat, Dr. Vijay Kumar Dala from NIT Jamshedpur, Dr. Ramesh Kumar Gupta sir from Shiv Nadar University, Delhi NCR, Dr. Manoj Kumar Gupta sir from Institute of Plasma Research, Ahmedabad, Dr. Chaitanya Desai sir from CK Pithawala, Surat, Dr. Parag Rajpara sir from Marwadi University, Rajkot, gave their full support to make this FDP successful. I conducted hands-on training program along with our industrial guest, Mr. Kailas Jagtap from ARK Infosystems and Mr. Jigyasu from Integrated Microsystem. Here, this hands-on training was mainly focused on ANSYS software. Being coordinator of this FDP, I myself and Dr. Hitesh Solanki attended all sessions, delivered the basics of finite element method at the elementary level. We hope this FDP will be fruitful in future to all participants in their academics as well as in research activities. All sessions having good strength of participation, and also participants were eager to interact with the experts. All the sessions were found very interactive, interesting, and highly informative. The FTP was organized on MS Team platform, and all the sessions were online live telecasted on YouTube also. I am not taking, we are interested to hear a lot from our participants. Herewith, I am welcoming our chief guest. Thank you all. Please, Professor Deepa Pandey madam, kindly go with the further proceedings.
Thank you so much, sir. Let us proceed with the event now. I would like to invite our respected principal, Dr. Sanjay Joshi sir, to welcome our chief guest, Honorable Dr. Sachin Parikh sir. I will also request Dr. Sanjay Joshi sir to motivate us on this occasion. Sir, please.
Thank you, madam. Dr. Sachin Parikh, Joint Director, Establishment, Commissionerate of Technical Education, Government of Gujarat. Dr. R.K. Shukla, Professor in Mechanical Engineering, Mechanical Engineering Department, GEC Bharuch. The young and dynamic coordinators, Dr. Hitesh Solanki and Ashish